Okay, so let's take a look at this first correlation question now. So a language teacher wished to test whether there is any correlation between the student's ability in their own and a foreign language. Accordingly, she collects the marks of 8 students, all native English speakers, in their end of year exams in English and French. So the first thing that we're going to do is use our calculator to determine the product moment correlation coefficient. Now, there's nothing in the Welsh Joint syllabus that says that you have to be able to do this. It actually says that you will be given it. However, because the calculator can do it, I think it's a useful skill to get to grips with. So on our calculator, menu, statistics, which is 6, and this time it isn't one variable, it's a linear regression, a linear correlation, so it's going to be the equation of a straight line, number 2. That now gives us our spreadsheet with 2 columns. So if we put English in as column X, takes us to 8, so we know that we're on the right track. Move across, and if you push down once, it takes you to the start of the next column. Okay, so we're done. Then, just like with a single variable statistics, we hit AC, all clear, and option. And this time, to get the value of R, we go to 3, the regression calculations. What regression does is give you the values of the equation of the line of best fit, which is also something that's no longer in the Welsh Joint syllabus, but it also gives us the correlation coefficient. So if we click on 3, we can see there the constants that go into the equation of a straight line, but also R. So in this case, the correlation coefficient, the measure of correlation between our pairs of variables, is 0.913. Okay, state our null and alternative hypotheses. Well, the null hypothesis is always there is no correlation. Now we're talking about the correlation of the population, the parent population, not the sample. So there is no correlation between performance in English and French. And then the alternative hypothesis is that there will be a relationship, and it'll be a positive relationship. So the correlation between the parent population will be greater than 0. There is a correlation between, etc., etc. So we're going to carry out this test at 5% significance level. Testing at 5% significance, and it'll be a one-tail test. So from our tables then we will get a critical value . And that will give us a value of R. So we have got 8 students, so N will be 8. I need to do a one-tail 5% test, so I'm going to cross the top row 5%. The critical region is going to be 0.6215. So that's my critical region. So in order for us to accept the null hypothesis, the acceptance region which is how it's sometimes described, we would need the value of r to be less than 0.6215. So if our calculated value of r, which is our test statistic, was less than 0.6215, we would accept the null hypothesis. So our test correlation coefficient R, which is 0.913, is not less than, it's greater than the critical value, so we reject the null hypothesis. And then, just like when we were doing the calculated means sample, we then need to bring that back into the context of the question. So we can say, hence there is sufficient evidence to suggest a positive relationship between English and French test scores. So there you go. Now, as we work through these examples, just like when we're doing the calculated mean, we'll try to keep the stages that we break through in the same sort of order, so that you become familiar with the steps that you need to take.